Kia ora and welcome to video 12 in the series Insightful Integration. We're back to a contextual problem here, a pretty strange context to be fair, not something you typically see in a calculus exam, but maybe more so physics. We've got a radial probability distribution that tells us the probability that an electron is a distance r away from the center of an atom. Pretty interesting. We've got this probability distribution, which is quite cool because if you do stats, you kind of understand that as well. And we have to evaluate an integral. Even if you didn't understand the context, we're just integrating something. The integral itself is an absolute mess. And the hint down there is the integration by parts formula. If you haven't seen it, it is a very, or it features very commonly in previous scholarship exams. Integration by parts is something that's in the Cambridge curricula, and you'll see again in engineering and mathematics at university. However, it is actually just the reverse product rule, so it's a fair game to put it in the scholarship exam. You actually need to use it twice to do this integral. So give it a crack. I'll be very, very careful with your algebra in this video because the expression itself is quite messy, and one small mistake, as I made in the first recording of this, can make all the difference between you getting the right answer and not. We'll see you on the flip side for the solution. Okay, so this problem on the surface looks fairly straightforward. We have a pretty strange function here, but all we need to do is anti-differentiate it, or integrate it between 0 and a0. A0's a constant, so we're just finding a definite integral. The function itself is messy and it's got a product of two terms, so we need integration by parts. If you've never seen integration by parts, this is probably not the video to learn it. Heaps of videos on YouTube that will help you in more depth, but we're going to use it not only once, we're going to use it twice. Integration by parts, this formula here enables you to turn a product of two things, or an integral of a product, into a simpler integral, and we want the right hand side integral here, this f dash g, to be simpler than what we start with. So that gives us a hint as to what we should make f. That f dash needs to be simpler. Okay, so we've got an integral. We can pull the 4 over a0 cubed. We can pull that out the front of the integral because it's just a constant. We just see what I've done there. This whole thing's a constant and so is the 4. So pull that out the front. We're integrating between 0 and a0, and we're integrating r squared e to the minus 2r over a0. So, like I was saying, if we let f equal the r squared part, because f dash will reduce down to something easier, the g dash part of the integrand will be the exponential term, and it's antiderivative. Be careful here, because like when you use product rule for differentiation, you find f dash and g dash. Here we've got g dash. We want that for g. Okay, you can just check that that differentiates back to the same thing, and then if we sub that into the let's just not worry about the limits for now, but we've got 4 over a0 cubed multiplied by fg. Okay, the first part of the integration by parts formula, fg, is going to be negative a0 over 2 r squared e to the minus 2r over a0 minus a new integral, and the integral here is f dash g, which is 2r e to the minus 2r. No, it's not. It's 2r multiplied by negative a0 over 2 e to the minus 2r over a0. Okay, that integral is easier to do because the product, it's still a product of two things, but the first term is reduced down. Let's play around a little bit with the constants here. We've got the first term, the 4 over the 2 simplifies, the a0 over a0 cubed simplifies, so we're left with minus 2
Actually, no, I'm just going to leave the 4 over a naught cubed in the front. It ends up cancelling at the end of this problem, but I'm going to just leave that there for now. And I'll just deal with this integral. I'll pull another constant out of this integral. The 2's cancel. We've got a minus a naught that comes out the front with the other negative. So a naught integral r e to the minus 2r over a naught, and repeat the process. Use integration by parts again, but this time we let f equal r, f dash equals 1, g dash is the same thing as what we had before, so g is the same. We don't have to worry about an integration constant when we're using integration by parts. We don't have to worry about g having a plus c there. Okay, sub that in. Okay, so a naught times, now again we use the fg as the first term. It can be so easy just to lose one little part of the each term, and then everything won't cancel. The question is to find a probability, so a number between 0 and 1. It turns out the probability doesn't depend on a naught. So if we lost in it, or accidentally put an a naught in one of the terms, we're not going to get everything simplifying at the end. So you've got to be very, very careful here, especially with this fact that we've got a minus another integral, and the integral here is f dash g. So, and because g's got a negative in it, we've got to be very careful of extra negatives. Okay, lastly, we've got to find that last integral. Oopsies, let's actually expand that term. Minus a naught squared over 2 e to the minus 2r over a naught, and then be careful, this a naught here is in front of both of the terms in that bracket, and we've also got a double negative in there, and we can pull that constant out the front, so we're left with a naught squared over 2 multiplied by the antiderivative of the thing we've already been anti-differentiating here. That's multiplied by, we don't need integration by parts on this last one, it's just minus a naught over 2 e to the minus 2r over a naught. Alrighty, now that looks horrendous, but remember that the last step is to sub in a naught as the top limit and 0 is the bottom limit. Be careful when you're subbing in, because normally you'd think, oh, subbing in 0 cancels things, but there is a term in there that doesn't have an r as a factor, so 0 does need to be checked. 4 over a naught cubed. Okay, let's sub in a naught first. We're subbing it into the r values. When we sub in a naught into the first term, we get an a naught cubed, okay, because there's that whole term there, there'll be 3 a naughts, and that's going to cancel with the a naught cubed there. We're going to get the same thing with the second part. Second term's got an a naught cubed going to be cancelling, and the third one's going to have an a naught cubed cancelling. So in fact, we can deal with that straight away by just cancelling those. We've got 4 out the front, multiplied by negative r squared over 2. Oh no, that's very, very dodgy. I can't do that because it's subbing into the r value. It's only a naught cubed when we sub in a naught. Okay, apologies, leave that there. Okay, we've sub in a naught, minus a naught cubed over 2 e to the minus 2. The a naughts cancel in the power. Minus another a naught cubed over 2, minus e to the minus 2 as well. And then the last one, minus a naught cubed over 4, e to the minus 2. Okay, and then we sub in 0, because that's the first substitution. Take away, sub in 0. The first term disappears because it's an r squared in there. Second term also disappears, and the third term is minus a naught cubed over 4 e to the 0, which is 1. So we're left with a term there, like I was saying, 0 didn't cancel everything. And then if we run through and put all those things together, we've got some like terms there with the e to the minus 2, and all of them have an a naught cubed in them. So now we can play the cancellation game, which is fun. Cancel that, 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 and that, and we've just got a number, which is what we were expecting, a probability. It's got to be a number between 0 and 1, so that will be a little bit of an indicator that we've done things right. We've got minus a half, minus another half is minus 1, minus a quarter is minus 5/4, e to the minus 2, and then that last term is plus a quarter without an e, without an exponential term there. And then the 4's cancel, and this better be a number between 0 and 1, otherwise I'll have to spot the error. We've got equals 1 minus 5 e to the minus 2, and that's approximately 0.323, and we'll leave it there. The probability of finding a 1s electron of hydrogen within a naught, which it turns out to be Bohr's radius, within a naught of the centre of the atom, according to this model, is about 32%. Interesting. I hope you enjoyed that video. The calculus involved wasn't too nasty. The care that we needed to take in the working with a naughts and negatives and all that sort of stuff was where it was very easy to make an error. And I'll admit now that this was the second recording of this video, because I did indeed stuff up. The first time I recorded it, I accidentally, on the right hand side of the integral, I used f-g', and if you remember about 5 to 10 minutes ago, I almost did the same thing again. So you've got to be very, very careful with these problems, because it turns a doable question into something that could be a nightmare in the end.